So, good morning, good evening, everyone. Welcome to again a new session of Global Power BI User Group. Today we have Phil with us to share a Power BI knowledge related to how we can do optimization. A really good stuff. I think this is really interesting. So before jumping into the session, let's see a little bit about the Global Power BI. So highlights of the Power BI is nothing but we have monthly sessions from industry experts. We have almost 30 leaders participations, and we have almost 25 country presence. It's more than 5 than the last. We have almost 850 Facebook members, and this list is growing daily. And I would like to thank all the volunteers who are helping us to solve the questions, solve the queries, get the information to the members. And we do have a LinkedIn user group also where we are posting all the latest update related to Power BI websites and any update related to where the people will have the knowledge. We do have started the registration process for our own members. So till the time we started, now we have almost 225 registered members where we can reach out to them directly and they get connected through sessions or through interactions in various user groups. This is our official page from the Microsoft community. Surely you can go ahead and claim your badge so that you will get the update regarding us. And I will share this slide at the session ends, and you can go ahead and connect with us in all the social media to get the updates on the real time. And moving over to the most important topic today, that how we can have optimization in Power BI. So we have Phil with us. He is veteran database and business intelligence professional with the deep understanding of Microsoft BI stack. And one thing I would like to say here, I see the Phil is really active on the community, Power BI community. If you have any questions, you can reach out to him surely. And this is really good that he have given some time to spend us today. So let's hear from him. So Phil, I am going to make you presenter.
Cool. Thank you very much, Vishal. It was a very nice introduction. I need to click something to turn on my presentation mode maybe. But while I'm waiting for that to happen, I assume you can hear me. Start sharing. Wonderful. So my name is Philip Seamark. I'm based in Wellington, New Zealand. I run the Wellington user group. We started in March this year and we've been holding monthly meetings. I also work for a company called TradeMe, which for New Zealand is a reasonably large size company. We have over 500 employees. Remember, this is New Zealand scale. We've been using Power BI for over a year now. We use it quite heavily. We have over half the company have pro licenses. So what I was hoping to do was perhaps share some simple techniques that we've found to be quite useful in optimizing Power BI models. We have a large number of desktop models. So I was hoping to talk a little bit about that today. So the key crux of the technique I want to focus on is the fact that Power BI Desktop is actually a tabular cube built into it. It took me a little while to realize that, but when I did understand that, what I realized was that tabular cubes have been around for a while now, perhaps 5 or 6 years, and there have been quite a variety of client tools that are available to connect to tabular cubes, both to consume data but also to monitor and see what's going on. So let's have a look at that today. So first of all, I have a Power BI desktop model with some simple data. It's based on some weather data, and if we have a look at the core facts table, it's not a large table, but we have 1.5 million records. I didn't want to have too much more than that in case I needed to read in the data many times during this presentation. But we're going to have a look at this particular model. The data contains weather readings from one weather station approximately every minute for over a year. And we have a series of measures that can slice and dice and review the measure. As you can see here, we can look at perhaps weather readings over a period of time. Okay, so what I wanted to show you was Power BI Desktop. When you start up Power BI Desktop, here a sub-executable is actually the Microsoft multi-dimensional server.executable. So this is in fact an instance of Microsoft Analysis Services running in tabular mode, which means any client tool that you would normally have the ability to collect to a tabular cube server can also be pointed to the desktop model. All you need to understand is what port the Power BI Desktop is listening on. When you close a Power BI Desktop session, it's gone and you can no longer connect. When you reopen a Power BI Desktop, it probably will be on a different port. So what you have to do once you start up your Power BI Desktop application is try and find what port is that particular desktop session listening on. There's a couple of ways that you can do that. The easiest and fastest way is to use the wonderful application called DAX Studio. This is a free application. Again, this was developed to help optimize writing DAX against tabular cube models. Hopefully you can see the screen. But as you can see here, I can type in the name of the tabular server. But fantastically, what it also does is I've got the ability to connect to any number of Power BI Desktop models that I have open. And the one I'm interested in today is this one called Power BI Desktop. So let's go ahead and connect to that. Now down here in the bottom, we have the connection details. So it's telling me that I'm connected to a tabular server on localhost : and here's the port number 61904. So this is the key piece of information that I'm interested in. So what that allows me to do is use any other client tool and perhaps SQL Server Management Studio, which is quite a common tool you would use if you were working with databases and cube servers. And I can make a connection, which I already have here, to that particular cube server. So let's create a new query window. I'm going to connect to my localhost machine on port 61904, and I connect. I can start writing queries against this. So perhaps I might type something like, and this is interesting because what I'm doing here is actually executing MDX against my Power BI Desktop model. So I'm asking my Power BI Desktop to give me the maximum temperature over all my months. If I run that, as you can see, and in fact we can extend this by perhaps putting in another measure. I just need to change my bracket style. So here we have, I am from a client tool running MDX statements against Power BI Desktop. I can also begin tools such as Sql Profiler, which again is a very good diagnostic tool used heavily when you're working with the Microsoft database engines, the analysis services engines, both multi-dimensional and tabular, but I can also point it to my Power BI Desktop file. So I can start up my SQL Server Profiler. You'll see here again, I'm connecting to analysis services on my local host on port 61904, and I will connect now. Profiler is quite a sophisticated tool. I can turn on a large series of events and events that it can track and trace, and if I start running that, it's now going to show me what's going on under the covers while I use my Power BI Desktop model. So I'm just going to clear the window and jump back to my Power BI Desktop and start actually clicking a few. This will force some queries to take place. So the queries are all occurring within Power BI Desktop. When I look back now in my Profiler window, I can actually go and see the DAX that has been executed. Now, I can't change this. This is not the tool that allows you to say, okay, this DEX seems really inefficient. I could now go and rewrite my DEX. But it does at least give you the opportunity to understand how Power BI Desktop is going about its DEX queries. So perhaps that might give you a clue to arrange your model in a slightly different way, where bottlenecks are. So each of these we're taking microseconds to execute. So perhaps this might show me where issues are. But you can also understand perhaps how the DEX has been executed. So this is kind of interesting and useful, but there's probably not too much you can do to optimize with this. Equally, other client tools such as Excel can be used to connect to my model. So if I choose an analysis services connection, local host port 61904, I believe, connect, and here's my model, connect and finish. I now have an Excel pivot table connected to my Power BI Desktop model. So if I go over to my Power BI Desktop model and I create a new measure on my readings, I'm going to create this measure and call this new measure equals 1. Save that, come back to Excel, refresh, and here I have my new measure. So this may be useful in a non-production way. Perhaps you enjoy the fantastic features of Power Query, being able to point that to an unstructured data source, suck data into Power Query and use the Power Query feature set to clean and tidy the data source. You can access that data in an ad hoc fashion using tools like Excel or whatever that can be pointed to a tabular cube to perhaps extract that data and put it into a data warehouse if you want to. Like I say, I wouldn't necessarily do that in a production environment. Hopefully the fantastic Power Query will find a home in tools such as SSIS quite soon. So what else can we do? Oh, DEX Studio, we can perhaps evaluate DEX. So we can run DEX against my, oops, I closed the window. So I connect to my Power BI Desktop and evaluate DEX. And run that, you'll see it's actually showing my dates. Interestingly here, this is a point I'd like to highlight. If I jump back to my Power BI Desktop model that we have been connecting to, I have 6 tables, 1, 2, 3, 4, 5, 6 tables, and there's a single DAX table. When we look at the model using tools such as DEX Studio and SQL Server Management Studio, it's actually showing 9 tables here. So what we can see are the under the cover date tables that support the auto hierarchy. So we can actually perhaps query those tables just to see what's contained. So these are not visible through the Power BI Desktop, but we can see what columns are contained there. Now this might be useful when you're trying to query these with Q&A, so to be able to query on the text month, day, date, etc. Again, helpful to know. These won't necessarily make your model any faster, smaller or better, but the more you know about your desktop environment, probably the better off you can be with some decisions down the track. So why do I care that I can connect to Power BI Desktop with all these external client tools that were really designed more to connect to Power BI tabular models? Well, obviously, Power BI analysis services, tabular models are all in memory. And if you have a finite amount of memory, say 16 gigabyte, 20 gigabyte, 32 gigabyte, and you have a large amount of data, you very quickly need to start making decisions when you're designing your tabular queue, whether I can save memory by not including some data in the model. And a common mistake is possibly the right term, new analysts might make is when they're building a data model, they quite often connect to a data source and bring in all the data. So perhaps I might have 20 columns. An analyst will bring them all in, and they might create measures on 3 of the columns, and they may only slice and dice on 4 of the columns. So you end up with 12 or 13 columns that are just never going to be used, but they still have an impact on the size of the data model. And the size of the data model will have an impact on the speed of general usability, plus will have an impact on your ability to save, move the data around, publish, all these sorts of things. Now this is just as true in the Power BI desktop model as it has been in the tabular cube world. So I'm going to jump back to my Power BI desktop model and have a look at the largest table, which in this particular case is a table called readings. All of the rest of the tables only have a small amount of data. So if we look at readings daily, we're talking 400 rows, standard measures 1, date ranges 5 rows, dates 700 rows, and in this particular case, readings has 1.5 million rows. Now, there's no reason why I can't have tens of millions of rows, hundreds of millions of rows, or billions of rows, so long as I make some good decisions about which columns I want to bring in and what I might do to those columns. So let's have a look at those. Well, in fact, actually, what I want to do is highlight in the tabular cube world about 4 years ago, if not before, Casper de Jong, who I understand still works for Microsoft, developed some Excel spreadsheets that could be pointed at a tabular cube. They run some DMV queries which bring back information about how memory has been used within that data model, and he would present that inside Excel to say these particular columns are where your bottlenecks are. And this has been useful to me, and I've used it many, many times on our tabular cubes, and I thought I definitely want to take advantage of this by pointing it at a Power BI desktop model. This is once I realised that Power BI desktop is in fact just a simplified, or 2016 tabular cube. So I did this with Excel, and the DMV that Casper executed within the Excel spreadsheet, he would bring the data back and he would use VBA within inside Excel to pull apart the columns, that the information that came back to present in Excel. And this works. This works well in Power BI Desktop. But I thought it would make more sense to actually use Power BI Desktop to do this job for us. So you can see here there's a DMV called select star from system discover object memory usage. So if I go to my Power BI, a second Power BI Desktop model, you can see here what I have done. I have a single query source, and that single query source happens to be my local host on port 61904. So I'm actually using a second instance of Power BI Desktop to point at my main instance of Power BI Desktop. I'm executing this DMV, and when the results come back, I'm using Power Query to simply and quickly pull apart that data. In fact, what I might do is show how simple that is by showing the same query again. So if we go new query, and we're going to choose analysis services, local host called 61904. Remember, this is going to bounce around. Database, I have forgotten the database. I might have to copy and paste that. There we go. So we do that. Analysis services. Local host 61904. Just go and get that query and paste that in. So here is the result set. I'm going to go OK. So this is coming as a query too. I'm going to delete this data source. Now this particular column was the piece of data that provided the most, or needed the most amount of code in Casper's VBA, because you needed to split this on a delimiter, and that's not always that straightforward in VBA. Whereas here I can simply split the data by delimiter, and in this case it is a comma. And what this gives me is a series of, it's not a comma, it might be space, Control Z, jump back here to get that delimiter. Full stop. So we'll fix that here by split comma by delimiter. We'll go custom split on and full stop. Wonderful. So that gives me a series of very useful columns in one step, which when I take back to the Power BI environment, I can easily review where memory is in fact being chewed up. So I can see here, I can drill down through those columns, which I've built into a hierarchy over here in the field list. Drill down, drill down, drill down through my dimensions, drill down through, if I have this in order of where memory is being chewed up, drill down through my table, through my columns, and I can see here that my batch ID column happens to be the largest user of memory in this particular model. Now I've cheated a little bit here, and I've deliberately left an inefficient column in the model to highlight how this will react once I remove that column from my main Power BI desktop environment and just simply refresh this data, which will re-execute that DNV. So if I jump back to my main Power BI model, you'll see this is the column I'm interested in, batch ID. This column here is chewing up the most amount of memory. And of my 1.5 million records, there are only 544 distinct values. So this column is highly unique, which is not a good thing. That means it won't compress down very well at all. And the reason for this is because I generally have maybe 1 or 2 readings every single minute. So this column contains the day, the year, the month, as well as the hours, minutes, and seconds. Now I don't need that. Over here, what I have is a column which I have built from batch ID, which only contains the date. And as you can see, of the 1.5 million records, there are only 495 distinct values, because this has been running for just over a year. Equally, I have a column which is based on the hour of this, and this happens to have, of 1.5 million records, only 24 distinct values. So between the two columns that I have here, I can perform still a very detailed level of analytics, and I don't need this column. So let's remove this. Wonderful. Now my report pages all still work quite happily because I never drill down to any granularity lower than day or hour. I have got hours. There we go. Hour equals hour. That's an incorrect measure there. Oh, we can add that. In fact, I can fix that. I'll remove this. I'll go back into my Power Query, and I will go to my readings table, jump up a step before I have removed that, and I will create an hour column. Go. That's the right data type, so I can close and apply. We already have a column called hour, which I can remove. And apply those changes. So that's going to reread in the data. 1.5 million records, 200 megabytes, should only take a few minutes to run.
So meanwhile, just one quick question. Which version
Sure.
of SQL Server you are using?
For the SQL Server Management Studio client tools, or Power BI Desktop is effectively SQL Server 2016 tabular. As for the client tools, you can connect to it from, I have used SQL Server Management Studio 2012, connects successfully. SQL Server 2014 and 16. Obviously, if you have 2016, it will expose more of the properties and features that might be available in 2016. Interestingly, if you do jump to here, you are offered attach backup. But if you do try and execute any of these, it'll take you quite far. But when it comes time to performing the backup, it'll say no. It's not encrypt. It'll say no. This particular model is running in diskless mode. You might be able to get into the XML and change that maybe if you want to perform backups, but you can't get in and create petitions or any of the other fun things that you can do yet on tabular models. So I hope that answers the question. So if I jump back to my model, so this is working now, and if I put hour into my axis, fantastic. So I can see here on given days how that particular day performed to the average of the date range. All right. So what we have done is we've removed the batch ID column, which was highly unique and was the column which was using up the most memory, and we've introduced a new column called hour. So I'm going to refresh this. By clicking refresh, it just issues the DMV query. You'll notice that batch ID has gone, and we have a new column here, and I can see exactly how much memory my hour column is using. So this is 0.5 MB, which is not a lot, but if I wanted to extrapolate my model, and rather than contain 1.5 million records, say I wanted to have 150 million records, then you would start to see where I would need to pay attention. If I look at the file size here, so Power BI Desktop, this is sitting on my machine at 12 megabytes. Now this is prior to the change. So 12.7 megabytes, I will now go back and save my Power BI model, and we'll see what that does to the file size footprint. That has completed now. So that's now 2.7 megabytes. Now I haven't lost any real data apart from the ability to perhaps analyze at the minutes and seconds. But I could still introduce a column for minutes and a column for seconds and keep that batch ID out, and I don't think this footprint would move much at all. So you can see the difference. If the amount of data I had was 10 times 100 times, this file size might be 10 or 100 times larger. So publishing to the web service, moving it around, just saving it in files, emailing it, whatever. It's a lot more efficient to have your model at these sorts of sizes. I've had a number of cases where analysts here at my organisation have gone to build their first model. Probably an extreme example, we had someone point to the data source and their original file size is 800 megs. Now, the limit at the moment to publish a Power BI desktop model to the web service is 1 gigabyte. So it was very, very close to that. So I suggested, let's have a play with this. I'll set you up with this, pointing the second instance of Power BI to the your desktop model, and let's see what we can do. And I didn't have to help them too much more than that. They managed to remove a lot of columns and proudly let me know that they had managed to get it down to 48 megabytes without losing any information that they needed to be able to report and analyze. So I thought that's pretty good and well worth sharing. So I also noticed on Twitter last week, actually, interestingly enough, Casper de Jong, who was the author, I'll just jump back to his original spreadsheet, he was talking about using an updated version of this using Power BI. And I sent him a message and said, oh, look, I'm really interested in this. I'm talking about this in the user group. Any chance I can get a version of this? And he was very helpful. So he said, it's a very early version, but here you go. And he sent it to me. And what I realized was that he was still using it to point at tabular server models, so not pointing at Power BI like this. And I said, oh, do you know if it will work against Power BI? And he said, I'm not sure. That's not what I'm doing. So I said, I'll give it a go. And with a small number of modifications, just in the compatibility level, I was able to do exactly the same thing, take his model and point it at a tabular, my Power BI desktop model. So here it is, 1.5 million records, and we can see where the record counts are. We can see tables by size, readings here. This is prior. I haven't refreshed this since I've removed my batch ID, so a lot of the charts here reflect. This is a really quite awkward tree map, believe it or not. There are some table columns over here, and we can drill down and find the similar effect here, that the batch ID was by far the biggest user of memory in this particular model. Once again, if I refresh this, it's going to update, and we can now see perhaps the readings table is now no longer well, it is still the vast majority. So they were probably the main things I wanted to actually cover in this session. So how are we going for time? We're sort of well ahead of where we needed to be. So I can take some questions, or I can perhaps have a look at a few other techniques. How does that sound, Vishal?
Sure. Till now we have two more questions. One
Sure.
was, can we able to see the same information for all the data source? Like, for example, if I have a data source from Wikipedia, can I able to see that? That's the question, I think.
Okay, that's a very good point actually. This particular technique is only useful when you import data into the data model. So it's useful when you bring it in any data source where you use direct query. So let's say you set SQL Server to be direct query, no data is contained within the Power BI desktop model, but then you're not trying to really optimize that for size. So it's not so much of an issue. So if you happen to point at Wikipedia and you suck in data into Power BI desktop, and that might be a large amount of data, then yes, this will work. This will work on any data source, be it JSON, be it any form of data, so long as it's being imported into the model, and when you save your desktop file, it in fact contains the data. So it's very, very flexible. The only thing is, and it will, you might have 10 tables, and they could all be quite large, and each table might have a large number of columns. You will be able to see which columns are chewing up all the memory, and then you can go to the decision point: can I remove the column, or can I perhaps do it in a slightly different way? So as you saw what I did there with dates, I didn't get rid of dates completely. I split it up and ended up using a lot less memory. And this is quite important with these in-memory models, with the compression technique that they use.
Awesome. Nice explanation. And once, if I will close the session of Power BI Desktop, will my port will change, or?
Yes, it will. So that's probably the challenge. Now, to find your port, there are a couple of ways that you can do that. The way I showed you before was using DAX Studio. That's probably the easiest. So if I close DAX Studio, let's say, reopen, and I highly recommend DAX Studio anyway. But at the very least, when I open, I hopefully you can see this in my connection window. It's telling me that it can see 4 instances of Power BI Desktop. I can choose the one I want and connect to that. And the main piece of information there is down in the bottom corner where it says localhost 61904. Another technique you can use is System Internals Process Explorer, which is an advanced task manager, free from Microsoft, very good product. If I find my Power BI desktop instance, and importantly, this is the executable that we want to interrogate. So on this Microsoft multidimensional server.exe executable, under TCP/IP, I can see that it is listening on, this particular instance is listening on 57629. So this isn't the instance that we've been using in the example, 61904. There are also a number of ways that you can access this information through the TCP/IP command line tools. So you can automate this if you actually wanted to make this particular step much more easy. The other step is you not only need to know what server to connect to, you need to know the database name. What I do is I use the SQL Server Management Studio. I connect to the local host, and here is the database name. So it's this long GUID. So I would create an NDX window and just simply drag it over, and this here inside the square brackets is the database name. So if I jump back to my Power Query window, the one that I'm using to interrogate this data, I'll show you where I have applied that here. So there's the server name with the port and the database name. So yes, if I close my Power BI desktop model that we've been looking at and try and refresh these, they will fail. If I reopen that, refresh these, the chances are they will fail because the port number will have changed.
Right.
I don't think the database will have changed, but it's always worth double checking. But you can find those details out certainly through Server Management Studio, which is a free product, and that would be available in the various versions of Server Management Studio as well.
Sure. And the memory checker dashboard is nothing but a dashboard of the dashboard to analyze the optimization, right?
Correct, yes. So if you really, really want to get a bit crazy, you can actually point it to itself. So you could have a dashboard showing the memory allocation of the DMVs of itself, which gets a bit circular. It's completely useless, but
That's really useful.
Yeah, BI humour.
Awesome. So that's the questions we have so far.
Okay. All right. Well, I mean, we're slightly ahead of time. So what I thought I would just spend a couple of minutes sharing is in the news you may or may not have seen that we have had some earthquakes here in New Zealand this week. I was interested after the event how many earthquakes we had, what size they were, where they were focused. And because Power BI is such a fantastic tool, I thought, all right, I'll connect to that. Here in New Zealand, I'm not sure if you can see this web browser. If I go to our GeoNet.
Actually, we cannot see your Chrome. If you can open a new session of Chrome, that will be good.
A new session of Chrome, okay. Can you see this?
No, even we cannot see that.
Okay, that's all right. All I was going to say is that there's the organisation here in New Zealand that looks after earthquake data provides a free API. It's if you go to a particular web address and put in a query, it will return a piece of JSON. The queries, we have a look at that JSON. So the web source is just www.wfs.blah blah 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 blah. That returns some JSON. You can walk through and convert that into a nice two-dimensional file using the wonderful Power Query tool. What I'm asking for here are the last 5,000 events that have taken place within 100,000 or 1 million meters of where I am at the moment. And if we go return that back to Power BI, I have here, I hope you can see this, all the earthquakes all the strong and moderate earthquakes that we've seen. Now I'm currently sitting here. If I pull back my date slider, include severe. Here was a particularly large one. It's now recorded as 7.8. And since then, if I take that off, we can actually see quite easily. Now this is of interest to me because we're talking about 20 kilometres from where I'm sitting to a whole cluster of earthquakes, and this is live. So when I click the refresh button, it issues a query off to the GeoNet API. It's usually only about 30 seconds behind, so when we do feel a shake in our building, rather than go to the website, I can just refresh my Power BI desktop, which I have access on my mobile phone, and go, oh, that was a moderate size one, and it was quite close to here, it was quite far away. So this is just a fun use of Power BI.
Yeah. And this is really amazing idea. Like think of it like, when we'll publish this same dashboard in the mobile, and we can set up a kind of a check where if it's going to be near to you, you can get the alerts. That sort of kind of, we can think
Correct. Of. Absolutely. And one of the neat features that they have added recently is the ArcGIS tools, and you can overlay things like fault lines in New Zealand and start to do some sort of semi-interesting analytics on earthquakes and fault lines. It's something that's well above my head though. So I just thought I'd share that because we had a little bit of time left over. But I do hope that anyone who's taken the time to connect today or watches this on YouTube has learnt maybe something about using Power BI to make Power BI models more efficient. Especially important when you start to deal with much larger data sets. And there's no reason why Power BI can't cope with billions of rows of source data. But once you start getting up into those sorts of numbers, you have to really start making sure your model's as efficient as it can be. And this is one tool that I think will definitely be useful to you. Many thanks to Casper de Jong who developed this idea many years ago. So.
Sure. Okay, for sure. So will you able to publish the Power BI template on the community website or?
Absolutely. So what I can do is put both versions, the one I just threw together and Casper's one. I can make that available to the global user group. So they're pretty basic, but you can enhance and improve them. They've got a potential to be quite good.
Sure.
And I will be adding this information into a blog onto the Power BI community blog site in the next week. So that will remind people what the details are, specifically what are some techniques to go and find that port number. And that's probably the most useful thing because that's going to change as you open and shut Power BI desktop.
Sure. And Phil, before closing the call, first of all, I would like to say thank you for a really amazing session related to optimization of Power BI. I am sure by looking at today's session, most of the viewers have, think of a lot of crazy ideas for sure, because how we can further see how Power BI is actually talking to the SQL Server and get the insight out of that. So this session was really, really useful. And I'm going to end the session with your last sentence. If you have anything to say, go for it.
No, I'm all good. Just thank you for anyone who has watched this today or will watch and enjoy this on YouTube. Thank you.
Thank you, Phil.